Hey folks, we hope you've had a glorious week. We're excited to welcome you back with another round of free Marketplace content. Our October set features a fully animated combat set, handcrafted movement animations, an easy-to-use multi-save solution, beautiful foliage, and a fully customizable loading screen system. In addition to all the timed free content, a robust JRPG template and modular sci-fi environment bundle have been added to our permanent collection. Download them all today. Soaked with info on the state of our oceans, 2D side-scrolling puzzler Coral was designed to be enjoyable for players of all skill levels, enthusiasts and casual players alike. To execute the goal, solo dev Carlos Coronado designed Coral's gameplay to use nothing more than a single joystick. In our discussion with Coronado, he details how scuba diving helped him capture a realistic yet surreal depiction of the ocean, elaborates on his drive to be a one-person studio, and shares tips for aspiring solo devs looking to follow suit. Dive into his interview after this. Already on the third evolution of their car configurator, Audi is trailblazing the use of real-time technology. With the most recent addition, vehicle changes are continually updated to the Unreal Engine files, meaning Audi dealers can now demo the latest version of the vehicle almost immediately. These real-time ready assets could also be leveraged to create even more projects, such as interactive service manuals, custom user-created videos, or marketing materials. All this vastly increases their return on investment. Do you have questions about UMG? Well, you're in luck, because we've got answers. Our own Chris Gagnon, lead programmer on Editor, assembled and provided a handy overview of best practices for UMG. His tech blog covers how to structure your UI elements in both C++ and Blueprints. Be sure to walk through his helpful example. And we want to extend our congratulations to Frogwares, who recently released their Lovecraft-inspired investigative thriller on Switch. We caught up with the team leading up to their launch to discuss their development process, to find out how they overcame design challenges, and to discover what inspired them to dive into the dark setting of H.P. Lovecraft. Now for this week's top Karna earners, we're giving shoutouts to Clockwork Ocean, Adno, Shadow River, Ailcon01, Indie Game Cove, Garner P57, Expose, Rumbleball, Hair Edgy, and Crewdimer. Thank you all for supporting other folks on AnswerHub. First up in our Spotlight section, This Dead Winter is a dark fantasy adventure game set in an ancient woodland suffering through an unending winter. You, a beautiful fox, embark on a journey across ruinous lands to find your missing cub. Follow their development on their page. Community dev Bartosz Komski has recently kicked off a series of 4-minute tutorials for beginners, teaching the basics of procedural materials, implementing footstep sounds, or spawning meshes in a radial. If you're just getting started, hop over to see how he may be able to help you on your journey. Last up this week is Daymare 1998, a third-person survival horror game set way back in the 90s, where you explore and uncover deadly creatures that lurk in sleepy Keensite, Idaho. All right, that's it for this week. Thanks for tuning in, and we'll catch you next time on the Unreal Engine News and Community Spotlight.
Hey everyone, and welcome to the Unreal Engine livestream. I'm your host, Victor Broden, and today I have invited evangelist Chris Murphy to come and talk to us about some of the adventures with shaders. You've been working a little bit on landscapes and other various cool topics. And just to start this off, what time is it right now for you, Chris?
It's 4:04 in the morning.
Chris is a champ, everyone. He asked me, what time is the live stream? And I said, well, it's 2 p.m. over here on the East Coast. And he returns, well, that's 4 a.m. my time. I'll do it. So big up, everyone. Chat. I'm happy you're able to do this.
He's exaggerating a little bit. There was a definite groan before the words "I'll do it." So that's.
Well, okay, fair enough. There was a bit of a conversation in between, but he said, "I'll do it," and you're here today. So very happy about that. Before we get started, I'd like to let everyone know that we will be handing out keys to Daymare 1998 in chat. So keep a lookout for those. There will be a little link to an image, so you actually have to type them in manually. Yeah, and with that said, I think it's time to get started. What is your first thing today, Chris?
So I'm going to be running through a couple of effects. I'll be honest with you, I'm not running really at 100%, just due to the time zone difference, but I'm going to step through a few different things. Now, I kind of last minute changed up some of the topics I was going to cover, but I'm going to begin with a couple of just little landscape things that I've noticed a lot of people don't do that I would like people to just be aware of. After that, I'm going to move into the procedural building stuff that a few people have seen me do on Twitter, which I should be able to remake from scratch reasonably quickly. Um, After that, I'm going to move into some kind of interesting post-processing effects and concepts, and then finally, I'm going to touch on the uh, pre-skinned position and pre-skinned local bounds nodes that have come in various versions of Unreal, but we haven't really. I haven't seen too many teams really taking use of them yet, and I want to stress to teams why these things are powerful. So, because I'm unfortunately running on Australian internet from home, I'm gonna have to kill my video feed while we're running this. So,
Yeah, we were not
it's
able
been nice seeing you all.
to do both at the same
Switching over to
time.
my screen now. Yeah, we have to pick one or the other in Australia.
I
Here we
think
go. Just
most of us
switching
are
up my
excited
camera and
about the
switching
editor.
over to the feeds coming through now. Great.
Yeah, we see it. You're all good.
Rad. Okay, video games. So, we have a very basic environment that's coming through at the moment. We've just got this kind of empty area, and I'm going to use this as just kind of a test bed for what I'm going to be developing from here on out. Now, the first thing that I want to do, and I'm going to try not to move the camera too quickly because I know we're running at like 1 frame a minute, but the first thing that I really want to touch on is landscapes. Now, there's a very simple little option that if you're going to be using a lot of foliage, I'm not sure if you'll be able to see it very well in this video, but you should be seeing a lot of popping going on with this grass
Well, it's coming
as
through.
I move forward and backwards. That's coming through okay? Oh, what a world. All right, so I'm going to load. Just be aware, folks, that to fix your LOD popping on assets is literally as easy as opening up the material and clicking this dithered LOD transitions and then just hitting apply and then moving on with your life, because seriously, that's all it takes. And what we'll get in return is your grass will now actually do like a nice screen door fade between each version. Now, because I just applied it to a grass that has like 4 or 5 variants, it'll take a second to build shaders. But hopefully you'll see where I'm kind of going with that and why that's advantageous. I've provided B-roll for a couple of different effects that we'll be doing today as a just in case. But you'll now notice that as I move forward and backwards, we're no longer kind of getting that effect. And I know it's a really simple thing where like Chris's first thing to show you is a checkbox, but for anyone that's unfamiliar of what my role as an evangelist is, basically across Australia, New Zealand, and Southeast Asia, my job is helping teams. So sometimes it's obviously just meeting people at conferences, but other times I'm on site for a day here and there for different teams, or dropping in for an hour to check out things. And there's a lot of commonly reoccurring issues that we really see popping up. So it's just little things like that kind of checkbox that I'm always kind of flagging. If you've following me on Twitter, you're probably used to me generally harassing people over these checkboxes. Obviously, the heathering here has not been set up to do it, but you'll notice that we're no longer just getting that pop in the grass. So I just really wanted to stress that as the first thing. Now, the next thing that I wanted to go into was quite often this language of smart materials gets thrown around. And anyone's talking about a smart landscape material, it sounds like a really, really complicated thing, and it sounds like there's going to be work in there, but it's straight up, like, it's really straightforward. And I really want to show people about how to approach a little bit of logic in your landscape materials to get you a long way. So I'm going to load my simple landscape material that we've got running at the moment, okay? So this is the one that we're seeing in the world right now. It's nothing too fancy, but I want to run through a couple of things that it's doing. Now, first off, when I open this up, first off, when I open this up, what I've got is, if I go to my paint and I just paint in a little bit of dirt, you'll notice that as I paint this in, that grass is disappearing and reappearing. And plenty of Unreal users are going to be already aware of this one, but I just want to make sure that everyone is, especially if you're new to the engine, you've just started looking at things like these live streams. In my landscape material, if I scroll down here, you'll see I've added this thing called the landscape grass output. And what this actually lets you do is the values that get read into this, if it's a 1, it will automatically spawn grass meshes at that location. Now, because that's coming through like with a value of 1, it's spawning grass. And a little cheeky thing that I'm doing is I'm doing a 1 minus value over here applied to a texture. You can see the texture here, which is essentially just swapping it every now and then. So sometimes it's grass, and when it's not grass, it's flowers. But both of them are looking at the landscape layer weight of the landscape layer called grass. So this will actually go ahead and just spawn those meshes. And this just feels, I mean, just for perspective sake of what this looks like if I didn't have grass enabled, look at that thing. What is this? Amateur hour? No. So having this kind of setup just feels so much nicer. It feels like a complete product. And it's really not that much work to just get it following a simple couple of rules and have something running there, okay? So do me a favor and just make sure that those things are in place. Now, the other thing that I really want to stress is go back to your landscape. Now, at the moment, landscapes can end up a giant mess, okay? But what I often find is a really nice way to handle these things is you'll see here that I have a thing called ML Dirt and another one called ML Grass. So this isn't anything fancy. I've literally just created a material layer. And what I mean by that is if I open this up, you can see that this is the material for grass. And I'm calling set material attributes at the end. And I'm actually passing this around as its own little mini data type. And by doing that, it means I can just kind of crunch down all of the dirt logic and all of the grass logic into a single instance, like a single node that I can just drop in. Now, not only does this allow me to have fewer nodes causing chaos in my landscape, it also gives me the added advantage of being able to have, if I ever need to use dirt in my project, I can literally drop in that ML Dirt layer and share it between different assets. So if I drop in a tree and it needs to have dirt or grass or something at the base of it, I can resample those things, use the same textures, and not, have all of that extra complexity for no good reason. Now, the other reason that I bring it up is because also you can then use this blend material attributes node, which literally acts like a lerp, but it lerps entire materials together. And we're going to be using a little bit of that today, okay? So to give you a quick example of what that means, let's for a second, let's add in an entirely new material layer, okay? Now, I'm going to use the set material attributes, and I'm just going to create it as a spot here. I'm not going to create it as a separate material function. But to do this, I'm just going to quickly drag in some textures. I know I have some sort of rocks available to me. Basalt, there you go.
Hey Chris, if you're able to, when you're zooming real quickly, it's coming through at a little low frame rate. So just try to be a little slower there, and we can follow along. All right?
Yeah. No. Heads up. Please direct all concerns about my internet speed dm.gov.au, and we'll go from there. So with this here, I'll try not to do any sharp zooms, but we've got this rock basalt texture and just this normal map. I'll just preview this on the asset so you can see what's up. Nothing too fancy. So I'm going to get this, and I'm going to add what's called a world aligned texture. Okay. Now, when I add a world aligned texture, what this essentially does is if you imagine a projector was placed along this axis and a projector was placed along this axis and another one on this, and they were just shining their light at whatever was there, it blends those three images together. I'm actually making hand motions right now that no one can see while I describe this.
Next time, you'll be in the studio.
Next time. Oh, thanks, man. So I'm going to get this, and the first thing you need to know is that when you're handing a texture to a material function, they need to be handed off as a texture 2D type. So this typically outputs just the color values, but I need to actually output the entire object. So you can't just plug it in. But to do it, you literally just right click and hit convert to texture object and just plug that in, okay? Now, because I'm going to need to start previewing this, I'm going to go ahead and I'm just going to call a set material attributes like that node you saw just before. I'm going to add 3 channels. I'm going to add a base color, a roughness, and a normal channel. Okay. Now, for the time being, I'm just going to plug these in, and I'm just going to preview it over here. Okay. Now, when I preview it over here, I'm just going to go to a sphere. You'll notice here that unlike before, this sphere actually has no pinching going on at the top of the sphere. And that's because it's just projecting this texture in space at this thing. And the reason I'm doing this is because what we can actually do is we're going to use this texture as a way of projecting cliffs into our landscape. Okay, so I'm going to right click and I'm going to call blend material attributes, and I'm going to blend between the existing landscape material where we have dirt and grass, and I'm just automatically going to add cliffs anytime it's sideways. So the next thing that we need to know is, well, how do we do that? Actually, just before I do that, I'm going to quickly set up the roughness value so that it doesn't look terrible. Now, in a situation like this texture that I'm reading in is pretty close to grayscale. So if I was to grab just the red channel from it, I'm going to use that as a black and white mask, and I'm going to run that into a lerp, and I'm going to tell the lerp that, hey, whenever the value is purely bright, I want that to have a roughness of like 0.8, and whenever that value is super dark, I want that to have a very high roughness value because I don't want to have like the shiny crevices going on. This is just a quick way of me just getting around not having a roughness map for that texture. Now, that's now that's going to be the rock, the cliff face that we're kind of bringing in. And oh, actually, one little thing I'm going to add is just a scale, and I'm going to plug this into texture size. And this actually kind of controls how big that projection going onto it is. And if I was to set this to 512, you'll see that, give it just a second. Sorry, Victor, I know I'm micro zooming. It's a force of habit. You can see here that like if I set that to 512, it's quite large. If I was to drop it down to 20, we'll see a tiling texture. So in this situation, I'm just going to set it to 512 and move on with my day. Now, the next thing that we need to do is work out how we're going to blend between top and sideways. Okay. Now, to move between sorry everybody, there's a couple of things dinging next to me. So to move between this and this version, what I'm actually going to do is I'm going to use what's called a normal in world space. Okay, so I'm just going to preview this node and hopefully I can explain it sufficiently to everybody. Now, for just one moment, if you're unfamiliar with using this node, that's fine. What I want you to do is look down in the bottom left-hand corner of my screen, and you'll see that we have X, Y, and Z. Okay. Also, it's really nice using the word Z instead of Z while talking to an American audience, but that's what you get. All right, so we've got our X-axis, our Y-axis, and our Z-axis. And you'll notice that those colors correspond to red, green, and blue. And if I was to look around here, as something is along the Y-axis, you'll see that it goes to green, and then it goes into what seems like black. But actually what this is doing is giving me a value of -1 on the green. Same thing goes for here, whereby the X is a value of 1, and over here it's a value of -1. Now, all of this basically tells me which direction the surface of the sphere is actually pointing in. So the more blue it is, the more upwards it's pointing, okay? Now, by knowing that the more blue something is, the more upward it's pointing, I can get this and I can say to it, hey, I just want your blue channel or your Z-axis, okay? Now, that's now going to give me a value that when it's completely facing upwards, it's white. And when it's down here, it's going to approach a value of 0, value of black, right? Which is actually pretty close to what we need here. But the truth is that I really want to get this rock kind of blending in nicely up top, so that it doesn't just do like a smooth interpolation into it. So one nice thing that I can do is I'm going to get this texture that I used earlier for this noise, and I'm just going to bring that across to here. Okay. And what I'm going to do is I'm going to subtract this value from this one. But even that won't quite be what I want yet. I'm also going to lower the scale here so they don't match up. So watch what happens here. If I was to get this and I was to subtract this channel and just preview it, you'll notice that we're now kind of getting this pulling away at it. And that's a lot closer to what we really want to be seeing here. So see how that's subtracting through. Now, just a quick little bit of logic that I want you, excuse me, hiccups. Just a quick little bit of logic that I want you to be aware of is if this value is white, all right, so if it's at its brightest point and I'm subtracting it from this value, what this means is that a value of white here, even subtracted from a pure white value up top, is still going to be equal to 0 in some set, when they line up. So whenever this happens to be a value of 1 up top and it's subtracting 1, 1 minus 1 is 0, okay? So what it's good to do here is to actually multiply. If I was to multiply this top section by another value, what we're essentially given is a way to kind of push up what these numbers are equal to. So I'm just going to call this Cliff Blend Multiply, and hopefully this will make sense in just a little bit. But as I plug this in, so what we're actually going to see here is notice that, actually I'm going to add a saturate at the end as well, just so that, okay. All right, so if you notice what's going on here, watch what happens when I change this value. See where that line is ending up? It's getting pushed further up and down as I change this. 54 was too high. But what that's essentially doing is this value was previously a value of 0 to 1, right? 0, 1. Now, this value is a value of 0 to 2. Now, by being a value of 0 to 2, it means even if this value is equal to 1, it's only what was initially a value of 0.5 that is now going to actually accept any change in its value, because 2 minus 1 is still equal to 1. And what a saturate is a clamp between 0 and 1. So it stops any value being above 1, it just makes it equal to 1, and it stops any value being below 0, it just makes it equal to 0. So I've done those two, and then the other little thing that I would really like to do in this situation is I'm going to use a power node. Now, a power node multiplies any value coming into it against itself, okay? So what that means is that I want you to think for a second of how, so 1 times 1 is equal to 1, all right? But 0.5 times 0.5 is equal to 0.25. Now, the reason I bring this up is because what that information tells us is that when we multiply a number by itself that's between 0 and 1, the closer it is to 0, the quicker it gets darker. But the closer it is to 1, the more likely it is to stay the same. So it's essentially a way of providing contrast to something that we're looking at, okay? Now I'm going to get this, and I'm going to create a new value called blend contrast, or apparently contrast. We can fix this. Excellent. All right, so I'm going to set this to 2, just initially. Now, by having these two values available to me, I want you to look at what happens to the white and dark values on this as I increase the contrast. 17 was too high, but see how that's actually pulling it up into it? So that's actually kind of allowing me to kind of create a really nice little blend here. Now, I have no idea of what's going to be a good value in this situation. That's okay. We're just going to plug it in and see what happens. So in this situation, I know that a white value is going to be standard landscape, and I know that a black value is going to be cliffs. Now, I can also, I'm just going to get this blend material attributes node that we've got. going to grab this. I'm going to say, hey, when it's white, I want you to be that. And when it's black, I want you to be that. By the way, little thing that a lot of people don't seem to know is if you hold control and click on here, you can just grab the end of a pin and plug it into something else. Okay. I say this because quite often I see people disconnecting and going back and plugging things in, and it just, that would be a waste of time. So I've got that plugged in now. That'll do for the moment. I'm just going to hit apply and we'll see how this works. Victor, is that feed resolution coming through okay still?
It's coming through all right. I do know that when you're compiling shaders, it definitely takes a little bit of a hitch.
Okay. In that case, I'll try to just keep things still whenever I'm compiling shaders. So with those things kind of plugged in, I'm just going to go back to the landscape and we'll let this thing just do what it does. Give it just a minute.
You want to take a question?
Sure. Let's do it.
What are the benefits or differences between using material layers versus material functions?
So essentially, they all get compiled down to the same thing. So your material layers, sorry, let me start again. Can you clarify with the person whether when they say material layers, they're referring to the material layer system that's experimental?
No,
or whether they
when
mean...
you made the what I thought was a material function, you said material layer.
Sorry. Okay. So in this situation, what I'm actually doing is a material function. A material layer is a material function in this situation. So as we've been bringing in the experimental material layer, I think there might be a different system for that. But essentially, it is just a material function. Like that's all I'm doing. I always use the prefix of ML to remind myself that the output of whatever this is, and also for quick selection, that this asset is going to be returning an entire material type. So I know all of the stuff that's kind of coming out of it. Sorry about that. That was me not clarifying very well. So in this situation, I'm just going to go back to here. Let's just grab this over to here. And I'm going to get the sculpt tool, and I'm going to just flatten for a second. And I'm going to pull this out. Okay, now I'm going to turn off grass for just 1 minute. We'll fix that up in just a moment. But you'll notice that as I pull it out now, what that's actually automatically doing is it's creating that rock texture whenever this thing goes completely vertical. Do you see that?
Yeah.
So having that kind of logic set up actually lets us create more natural landscapes that as we kind of just build cliffs, the cliffs are becoming cliffs. Now, what I'm going to do really quickly is just tweak these values so that it doesn't look terrible. The scale looks like it's okay, so 512 was fine. But what I will change is just this blend multiply to being something that's a little bit nicer. So I'm going to pull that to about maybe there. Going to get my blend contrast, and you'll notice that again, if I was to get this contrast, as I increase it, we're getting a harder edge, so that when it goes to rock now, it's just going straight into it. But if I was to drop this contrast right down, it's now going to be a softer blend between them. Now, if I was doing this in like an actual professional capacity, I would use a height blurb to kind of get it blending into the cracks of the rocks first. For anyone that wants to know how to do that, it's literally just typing in the word height blurb and just using this. It's pretty great. You can just use a height map and it'll blend between them from lowest values to highest values. It's a really good little node, but I don't really need to set that up to prove a point. So with this in mind and this kind of generally set up, the next thing that I'm quickly going to do is I'm just going to go back to where my grass sample was earlier. Okay, I'm just going to reorganize this a little bit. Grass stuff. Okay. Now, I'm going to get this and I'm going to multiply the existing grass value against, I'm going to multiply the existing grass value against this. And I'm going to add a value here called grass contrast. I did it again. There we go. So I'm going to set this grass contrast to like 4. And now if I re-enable, you can hit apply. But now if I re-enable grass, this should now make it, no grass will appear on the cliffs either. Because it's now using that same logic to do it. So while that's compiling, feel free to shoot through another question, Victor.
Sure, we can grab another one. So someone was curious about, can texture objects be used as material parameters?
As material parameters, yeah, you just get the... Ta-da!
So that, if you didn't catch that, that was a texture object parameter. I believe you can right-click the texture sample as well, right, and convert it into a parameter?
Yeah, no, you've got to convert to object, and then you convert the object. Convert to parameter. So either way, Bob's your mother's brother. All right, so if I go back and I look at this, my contrast here wasn't quite set up nicely. We're still getting a little bit of grass occasionally spawning on the cliffs. But I mean, that's literally just going to be a matter of me getting this cliff blend contrast. Oops, sorry, this grass contrast, and tweaking that until I get something. Unfortunately for this one, I do need to hit apply each time to get it to work out when is acceptable to bring in those cliffs and when is not.
And what would be the workaround around that if you sort of want to iterate a little bit faster without compiling shaders?
I mean, if you're willing to, in situations where I've had to really debug that and really preview it nicely, I literally just run this value out to the diffuse color for a little while. I just override the diffuse color, and I literally just preview the black and whites because I have a pretty good idea of how that's going to look when it all comes out. If you know what I mean?
Mm-hmm.
But that's not necessarily.
Do you usually use the master material for your landscape rather than making it an instance?
Do we use the master material for my landscape? Yeah. I try to for as long as I can until the point that I'm forced to change. So like, there's always a certain given point where you'll be like, all right, I guess I've just got to bite the bullet and do that thing now. But as much as possible, I typically try and run it this way because the problem is that if you build with instances, it's going to be recompiling your master and every instance the second you hit apply, and it just slows down your workflow massively.
Okay, that's a good tip.
So like it's good in the long run, but when you're doing that initial setup and you're just getting things working, it kind of just wastes your time a little bit. So as I said, like this is just kind of like a little bit, and obviously I'm doing it on like a tiny hill, so it's not really the best example. I really should have made a much larger thing, but hopefully that still gives you an idea. So I'll just pull this up for a second so we have a better idea of what's up. And again, I'm just going to grab this flatten node. And I'm just going to rip out some chunks of this. It's going to look a bit strange for a second until we erode it, so just bear with me.
What are the keyboard shortcuts you're doing to set the size of the brush?
These square brackets control the size of it. It's just the same as Photoshop. So I've got this, and yeah, and I just like to kind of rip this out. Now, if I set this up properly and I kind of tweak these values and I had a rock that wasn't just tiling quite as much, I'm sure you can kind of start to see where I'm going from. But a lot of people kind of look at this like it's some kind of like weird magic that's going on. But honestly, just getting this kind of set up for your material starts to just create automatic diversity in what you're seeing, which really just helps kind of get everything going. So I'm just bringing this together. So yeah, that was the first quick thing that I kind of wanted to cover with folks. Just let them know that that's entirely achievable. Now, the next thing that I wanted to cover was, so quite often people want to do a technique known as interior mapping. Now, let's take a, I'm getting ahead of myself. Let's take a quick look at this. So I'm going to create a new material, and I'm going to call this M underscore interior map. Okay. Now, this interior map material, imagine for a second that you're looking at a building. Okay. Now, when you typically look at a building in a video game, it's just going to be the picture of the building's facade or windows. Okay. Now, I bring this up because I it's very easy to do something that's a lot more than that. But involves us using type of texture. It involves us using a cube map. Now, a cube map is, I'll open this asset up. So a cube map looks like this, okay? Now, to create this, I literally opened up the realistic rendering demo. So it's available from the Learn tab, so you can just pull this down yourself. All I did was literally just grab a camera scene capture cube, which takes a 3D photo for you. Okay, I saved that out as an asset, and that generates this for me. Now, if I was to get this texture and pop this into here, unlike normal, where you can just right click and hit preview, you'll notice that when I preview it, we get an error. And the reason that we get an error is because Unreal actually needs to know which direction inside of the cube it's currently looking at. So what happens if I was to get the reflection vector and feed that in? You'll notice that now when I look at this sphere, we're kind of peering through the globe. Do you see that?
Yeah.
So if I was to get the camera vector, for instance, you can see that it's now syncing up correctly. It's upside down, but it's actually syncing up as if I'm kind of looking through a little mini portal. Okay. Now, if I was to use this, like that logic in mind, all it's actually doing is it's feeding in a direction to say, hey, you're looking at this 3D thing from this perspective. Now, I bring this up because, check this out. If I was to go interior cube map, this is just a node. If I was to get that, okay, and I was to plug that into my UVs instead, it gets the cube map and it breaks it into nice little rooms. See that?
Yeah.
Now, by getting something like this is where we actually really start to see something that's kind of powerful, because watch what happens if I was to get this, and I'm just going to apply this to a cube in my world, okay? Do I have a solid cube to use here? All right, I'll grab an engine cube. Sorry, I assumed I would have a cube because that's... Okay, cube. So just for a second, I'm going to apply this. I'm just going to drop that into the world. And I'm going to apply my interior map to it. And I'm just going to embiggen it. All right, there we go. Okay. So you'll see here that now what we've essentially started to get is something that actually lets us look into these rooms, okay? Now the next little thing that I'd like to do here that I find to be quite useful is I'm going to get this interior map, and you see this little randomized rotation boolean that's been set up? If I get that, I'm just going to read in a value of true, okay? And what that does, you can see it already happening there, but if I hit apply, it's actually going to randomize which direction you see.
That's
So see
super
now
cool.
we're using one cube map. We're using one cube map, but each room looks like a distinctive room. And this is really great because if we were to get something like this, all right, so that's really obviously just squares, but nothing stops us from setting the roughness value of what we're seeing here to be very low, like a value of like 0.1. And I'm going to plug this into, I'm going to multiply this against like a very dark value, like 0 in here. And plug that into my emissive. Oops, sorry, I'll stop previewing that. Because by adding that reflection, so by setting the roughness to a really low value and setting the emissive color to a very dark value, it now kind of looks like we're looking through glass, but behind the glass, it still looks like there's a room present. Do you see that?
Yeah.
So this is the first step for us doing something that's a little bit more interesting. Okay, and now the next thing that I'm going to dive into is definitely going to be jumping up in terms of advanced workflow, but hopefully it gets you a good idea of how to use this. So actually, give me just 1 second. I'm quickly going to import an asset that I had elsewhere.
I'll let you
There
do
is a
that.
cube somewhere. Yep, sorry about this. I'm just going to quickly pull in. One of these is a cube asset, and I'm currently not seeing it. Sorry, everybody. I just want to get a cube that's actually set up from the bottom rather than set up from... there it is. Great. Cool. Done. I found what I was after. I want to get a cube that's actually been set up so that the pivot point is on the bottom. And I know I could just duplicate an existing cube. I just want one that I trust. All right. Great. Now, the reason I've done this, so I've brought this cube in instead. Oh. Sorry, every now and then the Unreal Launcher can do this. Can we shake out of it or not? Yeah, there we go, popped it. All right, sorry, every now and then the Unreal Launcher can be a little bit finicky on that. And
Looks good now.
control of your window. Yeah, all fixed. So I'm just going to quickly swap this over to the cube that I just imported. And the reason I've done this is my cube that I just imported is the pivot point's down the bottom, because this way if I scale it up, it just makes it bigger. And if I scale it along the X or the Y, it's gonna do it accordingly. Now, what I would really like to do is I would like to get this building so that, and I'm going to revert it to being really visible. What I'd like to do is get this building so that as we made the building bigger, we actually added more rooms. Okay. So you can see here that as this gets bigger right now, it's just going to make the rooms themselves bigger, which isn't really what we want. We want the rooms to stay reasonably consistent. We just want to make sure that as it gets bigger, it does its thing. So there's a good way for us to handle this. Excuse me. And what we're going to do is we're going to go into this. And first thing I'm going to do is I'm going to kill the tiling. So I'm going to set this tiling, which is currently, as you can see, set to a value of 4, 4, which means 4 rooms by 4 rooms. And I'm just going to set that to a value of 1. Okay. Now, by setting this to a value of 1, it's just going to give me one big old room as we look through this. Now, the reason I've done this is I want to manually increase or decrease the size of the UVs, so the tiling through the UVs. And I'm going to do that according to scale. So here's a really cool thing that a lot of people aren't aware of. So let's begin by thinking about the problem that we have. What we really want to do is as the object gets bigger, we want to make it tile more along the directions that we see. So if you imagine that we were looking at the x-axis, which is this one, we would want the y-axis and the z-axis to increase how much tiling is going on based on the size of this surface. Does that make sense to how that would work? So what I'm going to do is I'm going to go back to the node that we used just before, which is I'm going to get the normal. I'm going to preview it. And I want you to think about what we actually have here. So this, when we looked at it as a sphere, gave us this. But when we look at it as a cube, we're actually given colors that correspond to the direction of what we're looking at. Now, these are negative values on their opposite sides. So red becomes dark, it becomes negative red. But if I put an abs function, what an abs function does is any value that would typically go into a negative now becomes positive. It's like the most optimistic node. So what this is doing is a value of -1 now just becomes a value of 1. But a value of 1, it stays a value of 1. Okay. So by getting this, what we're actually able to do is use this as the way of blending between the sizes. And you're probably like, all right, but how do we get the sizes? But that's actually super easy because you can literally call object scale as a node, which gets you the X scale, Y scale, and Z scale of the asset itself. So if you think about the problem now, I mean, really, it's just a matter of getting this and saying, I want to get this value, and I'm going to say to it, hey, whenever you were red, Okay, so whenever it's red, that's now going to give us a black and white value between here and here. So whenever it's red, we want to get the scale of the y-axis and the scale of the z-axis, and we're going to multiply it against that. And whenever this value is green, oops, I should really plug it in, that helps. So whenever it's green, we want to get the x-axis and the z-axis. Do you see that? So we're just going to get the x-axis and the z-axis. And I'm going to plug it into that. Now, fortunately, oops, sorry. There we go. Now, fortunately, this means if we look at the logic that we have going on here, now this one says whenever you're red, do this. And then we connect it to this, which says that whenever you are Y, do this. Which means that the only thing left is that if you're not X or Y, you must be Z. And if you're Z, if you're the Z, we're just going to get the X and Y. Okay, so I'm just going to append. I'm going to plug that in. Now, that little bit of logic there, just doing that, is now going to get me the scale according to any UV panel that we're currently looking at. Okay, so if I was to multiply that against a regular texture coordinate, which is just a standard UV map, what I'm able to do when we plug that in, now by default that should look completely normal. So I'm just going to apply. Yeah. You'll notice that now as I scale it up, it's just adding more rooms in. Do you see that?
Yep, that's a large apartment building.
My default size isn't great here. So, but we can fix that ourselves, right? Like this value is now just tied into this. So if I was to set the scale manually to be like 0.25, there you go. So now it's kind of just adding those in as I scale it up. See that?
Yep, you're a wizard.
And like, the whole point of this is to establish that I'm not a wizard.
I mean,
so,
you're just generating rooms there.
So like having this kind of going on is a really good way to start like processing how like having this going on is a really good way for you to really start processing like how we can approach some of the development of our assets in a much more interesting way, because all of a sudden we can start developing assets that are kind of intelligent enough to sorry, I have a lump in my throat. All of a sudden we can now start developing assets that are just going to do what we clearly want them to do. And it's worth noting for something like this that we don't have any blueprint involved. Okay, like this entire thing has zero blueprint. It's literally just a material that knows what it's doing. So having this kind of set up means I can be like, hey, I need a building here and I need a building here, but this one is going to be this. Now, it's worth noting that it's not that much extra logic as well it's not that much extra logic as well to automatically clamp the room sizes down. So like if you wanted to, you could comfortably get these values that are kind of coming in, and we could be rounding them out, you know, and if we round them out, it's actually going to stretch to the nearest room size. I'm saying this, I'm pretty sure this will work. So I'm just going to round that for the time being. Watch it. See that?
Yeah.
So it's doing it in 0.25 increments right now because I'm manually tiling. And this material is doing it as 0.25, but the round is happening before that. So really what I would need to do is have some sort of value called tiling that was multiplying this against 0.25. We're rounding that value. I'm going to set this back to just default. This wasn't actually meant to be in the presentation, but like,
Doing it live.
we're there now. Let's just so if I get something like this, okay. So see, it's now squishing the rooms right up until the point that it can fit a new one,
Mm-hmm.
which stops us getting like half rooms popping in. And honestly, like if you're playing a video game, no one's gonna notice that that's what's going on. Do you know what I mean? Like if they're playing, they're not gonna notice that this room is actually that squished. And if they do, you probably should do a better job of distracting them. So,
Could you show us
but as
the
I said, like,
could you show us the shader complexity of the current material?
yeah, sure. So that was actually the next thing I was going to be more shader complexity. It's going to happen. And it's worth noting, like you can get all of this that I've done, and you could comfortably throw it over the vertex. So that should still be fine.
What does that node do?
Vertex interpolator. So for anyone that's unfamiliar with the vertex interpolator, usually developers used to use custom UVs to pass things between the vertex and the pixel shader. If you do a vertex interpolator node, it literally just does this side on the vertex and converts it to pixels. So it just makes sure that these instructions are being done. Yeah.
Nice, that's super handy.
It saves this single node used in certain situations can save like massive amounts of performance. So please use it. It's good for you. Because like, yeah, I mean, anytime I make something like this, I always get someone who's just like, yeah, but how complex is it? And then I'm like, it's still green. Like, it's not as green as our Skydam over here, but we're still pretty good with how that's looking. And it's not that much extra work, you know? And it's funny because, like, these buildings are now going to correctly instance, whereas if they were blueprints with a whole bunch of different parameters set up, unless I was using custom prim data or something, these wouldn't batch together, but now they will. So like being able to have all of these buildings like comfortably kind of batch, especially if I just create a couple of instances that are the exteriors. And like I've got a more complete thread on Twitter for this that you're more than welcome to check out. My Twitter feed on that. It's about like a 20-step process where I've gone through this like bit by bit and really carefully explained everything, and then I've added some outer windows and stuff to it. And the files are available to download from that Twitter thread as well. So feel free to get these assets from there to kind of get a better idea of what's going on if you don't feel like going through this video and like recreating it manually. So how are we going for time at the moment?
We're still pretty good.
Okay. Yeah, good is a relative term, but yeah.
Do you want to take a couple of questions?
Do
you want to take a couple of questions that are in regards to what you covered so far, or do you want to move till the end?
Yeah, that's probably a good idea. All right, let's do it. Question time.
So they were curious, can you blend entire material attributes values in a single lerp node?
Yeah.
Yeah, that's it. Yep, you can do it.
Yeah.
Yeah, I think you were doing that. Actually.
Yeah, I mean that's literally all it's doing. It blends everything together. And the other thing is that's nice about it is if I look at that node and I click it, you can say, hey, when it comes to vertex attributes, just use A or B. But when it comes to pixel attributes, you know, I want them to blend. This can get around some issues that you get where you're using a texture to blend stuff that isn't quite playing nice for vertex attributes. And, you know, I mean, even if you didn't want to do it this way, you can still manually blend stuff if you need to. Like, at any point, I can get this and call get material attribute. And then I can be like, hey, I want the base color out of this. And then I can call set material attribute. And I want to set the base color. Now, the cool thing is that if I feed this into this, I could do some sort of instruction, and then that will now have all of these properties, but the base color will be set to whatever is plugged in here. So you can override just that one channel.
Do those add more instruction counts in the material? The get and the set material attributes.
So get and set are actually less expensive than using this, which a lot of people still use. Please don't use that. Yeah, but to my knowledge, I don't think this adds any instructions because I think they all get compiled out. Don't hold me to that, but I'm reasonably sure they get compiled out.
It would seem like they're just fetching and setting the data rather than doing an operation on it.
Yeah, I mean, I think it's just in the graph. You get, I'm sure someone from Epic that has a better understanding on that side will be able to clarify. I've never gotten to a point where I've been like, oh, woe is me. Why have I used so many gets and sets that my performance has been terrible? So I'm assuming that it's fine. And I've done some pretty complex stuff on some pretty low-end machines. So I believe it's okay. But hopefully someone else at Epic can kind of clarify that point.
Yeah. Can you separate the cubes slightly, like for doing an apartment cutaway, walls, floors, and ceilings?
Yeah, so you can do that. It requires a little bit more math to really kind of figure out how to do it. Essentially, what you want to do, if you think about the problem, is if you consider every value that's coming in. All right, I can probably figure out how to do this live.
We could also follow up afterwards.
So now let's just do it. So if I use a frac node, one of the things that a lot of people underestimate is the power of a frac node. Okay. Now what we're doing right now is everything that's coming in here is telling us how much this value is being multiplied by to end up at its new position, right? But if I was to get a frac node and plug that into my, I'll plug into the emissive color actually. So, okay, sorry, I just realized I forgot one thing. So, sorry, I didn't want the frac node from there. I wanted the frac node from here. Okay, so what this frac node is essentially doing, there you go, is the frac node is going to make sure all of our values are between 0 and 1. Okay, so if I have a value of 4.5, it's now just equal to 0.5. Now, that same math of a frac node actually lets us kind of like follow that logic through and say, well, if we know that this is how big each tile is, nothing stops you from getting these and kind of increasing and decreasing from either side, like squishing these UVs in. And by squishing these UVs in so that the value of 0 is here and the value of 1 is here, so they're further inside, excuse me, that's how you would kind of take that approach. So that would kind of push those floors a little bit together and kind of extend the walls. Now, the advantage of being able to do that is you can obviously create like walls going on in between the things, but it also means that you can run that as an external mask that would act as like exterior concrete. Now, I believe the version of the material that I put up on Twitter automatically adds, instead of squishing the rooms, it adds concrete to the top and the left and right sides. So it actually adds overall buffer size to like kind of add that extra concrete on either side instead of squishing the rooms themselves, which is a very similar piece of logic to what we're describing now. Any other question before I move on to the next thing?
I think I had one more here. Would there be a way to combine different cube maps as to get even more variations of interiors behind the window glass in one master material?
Yeah. I mean, we kind of start taking on the whole Ian Malcolm thing of like so preoccupied with whether or not you could, whether or not you should. But if you're wanting to do that, you could do it in a few different ways. So yeah, you could do that in a few different ways. It depends on how random you want it to genuinely be. But you could comfortably just run a lerp that switches, because these here, this is a UVW being fed into a texture, right? So there's nothing that stops you from having another one of these and then looping between them. Now you could do your cell selection as to like which face you're actually selecting in a few different ways. Obviously, Interior Cube Map is doing that itself by getting the randomization here. So if you want to follow the logic that they're doing along this true path, by the way, if you click hide unrelated, I can grab just this true logic. So if I was to get this, I want to focus the whole chain. So I want to get that, I want to get you, and I want to go, you're true, you're pulling in this data. So they're doing, like how they're handling that randomization is, I think, done over here. So you could use that same logic to kind of handle your own exterior, like secondary randomization that's randomizing between these textures themselves, okay? That would be one way to do it. Another way, if you wanted to really kind of make sure that like edges of rooms were kind of matching with one another, you could use a Sobol randomization, which gets you like 2D integers. It creates kind of like a grid of random cells, and the cells themselves would be the value that's being read into here, sealed or floored. So if this is an integer being read in, it's sorry, I know. I'm just going to preview it so you can see what I'm yapping about. So if I was to get this and I was to that should and let's see. Cool. Let's get apply. It would help if I it's getting me a random number, so it's oh, and I did the same thing again. Good job, Chris. I want to get you, and I want to seal you to here. Yeah, okay, that should work. In my head, that works. Yeah, there you go. So that's now actually getting us a random number for each single cell. So we could use those values that we're lifting out of it as a way of like interpolating between different things. But because that's reading in a grid position, shouldn't be too hard for you to read in corresponding grid positions for each cell so that this random and this random have the same seeded value. Therefore, they output the same yellow, which would make the lights in each cell kind of match.
Okay. Do these cubes?
I can't remember if I'm doing that in my Twitter version or not. I have done that before though.
If these cubes are not aligned to the world axis, do the materials still work?
As in, like, if I got this and I turned it sideways.
Yep.
And
Yep.
I did this.
That was one of the questions.
Yes.
There we go.
Yeah, they still work.
Future architecture.
Cool. Anything else?
I think that was it for now. I might follow up with some later on, but please go ahead with your next example.
Rad. Cool. So, sorry, I'm not quite running at 100%. So the next thing that we're going to do here is we're going to take a stab at post-processing in a slightly different way. Yeah, that'll do. All right. So just gonna shrink this down a little bit because it's really just a bit of an eyesore. But I will put another one in because I need something to demonstrate the thing that I'm about to do. All right, rad. So for anyone that's unfamiliar with it, typically when we create a post-process, this is, no, actually I'm going to roll back and explain what a post-process is. So for anyone that's unfamiliar with post-processing, essentially how it works is as the camera, it renders all of the stuff in the scene, it then runs an extra pass at the end that allows you to change like the exposure, it allows you to change the color balance and all of that stuff, right? But one thing that's really useful is we have this concept called post-process materials. Now, a post-process material is really, really useful because it allows us to actually create a material that is doing a series of instructions on the final image. So I'm just going to create one of them really quickly now. I'm just going to create one of them now. I'm going to call this m_post process let's just build like an outline shader or something, all right? So we're going to build a really basic outline material. Now, the first thing to do is really straightforward. You literally get this and you say, hey, here, post process, okay? Now, you'll notice that that just ditches all of your channels except for emissive color. That's good, that's fine. Now, as a quick thing, if I was to get this, I'm going to go scene texture. I'm going to go scene texture, and I'm going to select post process input 0. Okay. Now, just for the time being, I'm going to multiply that against. Give me a color, Victor.
How about green?
Green. Okay, let's do green, just as a quick thing. In fact, I'm not going to multiply it because that's going to look terrible. Let's do a Photoshop overlay. Well, Photoshop-like overlay, I should say, lest the lawyers get involved. Okay, so there we go. So that's now putting this image over the top of it. So see how that's going on there?
Yeah, we got night vision now.
We have night vision now. That's why you chose green. Good job. All right, so we're now kind of like getting that kind of blend going on. And if I wanted to, you know, I could hit apply, and I could push this out to the scene. Like I just click here and I say, hey, I want to use an asset, and the one I want to use is called post process outlines, which is now doing this. Okay, but what's really important here is if we want to, we could create an outline shader. Now, there's a few different ways to do an outline shader. I'll create like a reasonably basic one, I guess. So let's just follow through that logic. So I'm going to use a node called sample scene depth. Okay, and you could do this manually, but I find this is an easier way to quickly set up what I'm about to do. Now, imagine, so this node, given an offset, it will go ahead and it will look at how far away the current thing in the scene actually is. So what is the depth of the thing in the scene? Okay, now what we can do that's quite useful is that if I wanted to, I could get this and I could duplicate it. Now, I'm trying to think of how to demonstrate this next bit. Paint. Let's do it. All right. So pretend we're sampling this pixel here. Okay. If I wanted to look at, let me use a different color. If I wanted to look at this pixel and this pixel and this pixel and this pixel, so the ones that are above, below, to the left, and to the right, I could actually look at all of those and see how different they are to this middle pixel. And by doing that, I can see whether it's an edge or not, because if there's not much difference between these things, then it means it's probably a flat surface. But if there's a big change, it means that, like, there we go. If this is coming up with a really low number and this one over here is coming up with a really high number, I know that this is really far away, but this one isn't. Therefore, there's a line here. I hope that makes sense. So we're going to do that. Reasonably simple. I mean, all you need to do is, there's a nice cheap way to do it is use this blur sample offsets node, which already reads in XY, your XY offsets of 0, 1, 1, 0, 0, -1, -1, 0. So it's a quick way to do it. So I'm literally just going to get this and be like, plug in all of you. Okay, and you're probably like, all right, but that sounded like a reasonably complex task of evaluating these things. But actually, it's kind of not. I mean, if I got this, all I need to do is I add all of these together, and then I see how different they are to this one. To do that really just means if I was to multiply this by -4, because there's going to be 4 of these things, and then I add everything together.
I think we lost your screen share there for just a little bit. Okay, you're back.
Oh, did you get all my audio or just a screen share?
I think it was a full hitch. It was only
Full
a couple
hitch.
seconds.
Okay, what was the last thing you heard?
-4?
Okay, so by multiplying this by -4 and then adding everything together, this -4 is now, it's the equivalent of kind of adding this and then subtracting this, adding this and then subtracting this, adding this and then subtracting this, and adding this and then subtracting this. By multiplying it by -4 ahead of time before I just add everything together, it means that I only have to add it one time. I hope that makes sense. So by having this kind of set up here, so I'm getting all of those things, and what that's kind of doing for me. Well, actually, you know what? I'll just show you. If I get all of those values and I was to saturate them, look at that.
Yeah, it looks pretty cool.
So if I look back in my world for a second, this is what we see. And that's because that's creating like a reasonably basic out. Now you'll notice it might be hard to see because like it's getting pretty framey. But if I was to get this and it's getting a bit of jitter going on, but you can fix that jitter by just getting this post-process material and saying, hey, I want you to happen before tone mapping. And what that means is when the anti-aliasing pass kicks in, it will actually smooth out all of the stuff that you're seeing there. Is that visible? Can you see what's going on there? Can you see a difference in those two?
I saw the difference here.
Wonderful.
It was
So as I
especially
said,
clear
like, that's
in
kind of like
all of the white
great.
White ones.
Cool. So that's a reasonably basic post-process, right? Obviously, we could have done this in a cooler way, but this is a reasonably basic, like digitized looking post-process thing. But let's do something that people don't often do. So let's go one step further. So I'm going to delete this from my post-process for just a moment, and I'm going to go back to here, and I'm going to grab this. I'm going to grab this. Actually, just before I do that, now that I think about it, it's not going to undo properly. Just going to apply this again. Sorry. One thing actually I forgot to mention for any folks that are following along at home is if that image that you just saw and I multiplied it, 1 minus just flips the zeros and the ones. If I multiply that against the post-process color, we're going to get that. Now, normally I would need to do some masking that removes the background stuff as well so that we don't get that happening with the skybox. But see how we're now kind of getting that applied to the standard imagery that we would otherwise see? Great. So I figured I should probably show people how to finish the owl. So we've got that applied. What I'm actually going to do this time is I'm going to get all of this. I'm going to copy pasta. I'm going to create a new material. That's going to be called M underscore. I'm going to call this box process. Now this is box process sounds. It's not quite what it is.
Names are important.
Yeah, I'm going to call it movable process. Okay, just as a reasonably straightforward way to do this. So, okay, so I've got this M underscore movable process. I'm going to delete the existing post processes, so we're back to where we were before. And what I'm going to do is I'm going to get a cube and just drop that into my world. Okay, and I'm going to make this a big cube. Now, one of the really cool things that a lot of people don't realize is that when something is running translucency, it can actually run almost all the same logic that your post processes can. So check this out. If I go to this and I say to it, hey, you are translucent. Okay, so if I say to it, hey, you're translucent, and I'm just going to plug this into the opacity. And then I'm going to hit apply. And I'm going to set this box up to have the material, I called it movable. Now, when we look through this box, we're actually seeing that post-process. Do you see that?
Yeah, it's coming through.
Being applied to it. Now, one thing that actually could be rad here is if I ditch that 1 minus, so we just have what we originally had, I could run it like this. So actually, you know what would look even cooler than what I'm doing right now that I think about it, is I'm going to multiply that against like a rad looking color of some sort. Let's do orange this time. That's right, guys. Color with a U. Live streaming from Australia. So I'm just going to plug. Let's see, I think this will work. All right, might look a bit psychedelic. That's pretty cool. All right, so we've got that going on there. Okay. So with this, with like what we can see at the moment, if I was to go into this cube, it's going to bleep out of existence. Do you see that?
Mm-hmm.
That's not good for anybody. So if I get this, I'm just going to literally make this two-sided. Now, by making this asset sided,
If you didn't catch
now
that
when
there,
we go into it,
Chris,
Sorry.
do you just want to show the checkbox again?
sorry, it says two-sided.
There we go, under details. Cool.
And now if I go into it, we're now able to look out. Now we're not out of the woods yet. We have this issue going on. Now, does anyone want to guess why this is occurring? Victor, you got an idea?
Well, the
Yes.
box is below the landscape.
Exactly.
Yeah,
so
so
it's
the
only going to be
internal
two-sided
face.
when we can see. Yeah, exactly. It's only going to be two-sided when we can actually see what's there. Okay. So, all right, that's a bit of a problem. So how do we solve this? Well, there's a really, really, really cheeky way to go about solving this. So please don't judge me for everything you're about to see. All right, now that I've put that forward, let's check this out. If I disable the depth test on this box, so there's a checkbox called Disable Depth Test. This will now render through everything. Give it a sec. So if I go into it, we can now see that that's occurring as well. Do you see that?
It's coming through a bit choppy, but I think we can see it now. Yep. Yeah, I've used that
hopefully if I go
that checkbox to do like player names on your team and such, so you're able to see
Yeah,
them anywhere
here's
in
the
the
problem.
world.
So here's the issue we're going to get. See that?
Mm-hmm.
Not ideal. Fortunately, there is a nice little thing that we can do, which is there is a thing called world position behind translucency. Okay. Now, world position behind translucency literally just gets you the position of anything you're looking at that's behind the object that you're seeing. So if it's a translucent object, instead of getting you the world position of the cube surface, it would be getting you the position of the grass or the building behind it. Do you get what I mean?
Yeah. And we're just a
So-
quick request to, when you're doing these quick motions and just showing the little things, just go a little slower, since we're a
Oh,
couple
yes.
of,
Sorry
couple
about
frames
that,
behind
folks.
due to the upload
Yeah.
rate.
Yeah. Sorry about that, everybody.
You're just too fast for us.
No, I'm just trying not to get into a political rant. So we got this world position. So if we get that world position, now the first problem that a lot of people have when they approach these kinds of issues is they don't approach these problems from the perspective of localizing it. But if we know where the inside of, if we assume that the inside of our box is 0, 0, and then like it's a local position, all of the math that I'm about to do becomes much easier. So there's a thing called a box mask 3D. And what it looks at two things and it just works out if they're inside of the box or not. So I'm going to get the world position behind the translucency, and I'm going to tell it that the location box is 0, 0. Now, this isn't going to work yet because I am missing something. This world position is in world coordinates, but if I transform its position so that it's in local space, so I'm going to tell it that it's the information coming into it is absolute, and I want it to come out relative to the box that I just added. I then just need to get these bounds and set them to the object's local bounds. Almost there. And I think if I plug this into opacity, we should see what we want. Oh, that's wrong. The bounds need to be the size, not the minimum. Trying to hold so that you can as I do it. Right, so do this again. What we have here is I can now move. I'm going to put this box wherever it goes. Provides a post process just to that region that you can physically see into, and then when I get in there with it, I can be like, post processing, and then I come out and it's doing its thing. So for that kind of effect, we could use this for all sorts of stuff. I actually gave you a reel earlier. Do you mind playing a thing for me that I sent you earlier? Can you play the one called Movable Post Process through your feed?
Yep.
Thank you. So I'll talk over the top of that. So this is something that I did as a quick demo when I was using this feature elsewhere. I whipped up a procedural level creation tool, so you could just walk through and hit buttons, and it would intelligently place bits and pieces in the world. But I'm actually using that post process concept of just like it's not actually a post process, like it is just translucency doing some fancy stuff. But using that as a spawn technique that grabbed all of the regular assets in the world and quickly just had them, the box is actually just shrinking down. If you see what's going on in that scene, see how it's just a box getting smaller and smaller? That's actually all it's doing. And it creates a really nice little spawn effect that you could use without having to do like a ton of extra pixel instructions that are actually on every single unique asset within the thing that you're spawning. So it's kind of nice to be able to just spawn stuff and be like, you're what I care about. And if you wanted to, you could probably use like custom depth or something like that as a nice way of masking out specific assets too with less overhead, So this could be approached in a few different ways, but a technique like this is very rarely actually used, but as far as I'm concerned, is really quite valuable. Now, if you don't mind jumping back to my share.
Yep.
So the last little thing I'm just going to show you on this front is if I go to this asset, if we were to, there's this value called edge fall off. Now, this isn't going to work out of the box. Box pun. But no, this isn't going to work out of the box. I'm going to create a scalar called edge fall off. Now, actually, you know what? I might actually show you the problem first so you can see what occurs. Watch what happens if I plug in an edge fall off of 200 straight into this. Okay, just look at what goes on. So, sorry about that, folks. One sec. So if I was to just read in an edge fall off of something like that and just kind of like, just plug in a value of like 200 or whatever it was that I just did, it's not going to work. It's not going to properly give me the size of what I actually I need it to be. So what I actually need to do here is I need to get the bounds, and I need to subtract the edge fall off size from that so that it actually brings it back in. So hopefully this will make sense to you in just a sec. I'm going to get that value. I'm going to subtract. Now the edge fall off is a radius, so I need to subtract it from both sides. So I'm going to multiply it by 2. I think this will work. That did not work. Oh, I actually did a little bit. Let me just bring the edge fall off to be a much smaller number. So that's now kind of creating that nice fade in and fade out of the post process. Do you see that?
Yeah, yeah, we see it.
Yeah. So by kind of subtracting that first, it actually gets you like a nice blend. And I've done some pretty cool stuff with this. Like I whipped up I put together a toon shader a little while ago, and it was really cool to like walk into a toon world and then walk out of the toon world. You know what I mean? Like that kind of stuff is really fun. And you can kind of create some really, really unique and interesting effects. So like being able to kind of like walk into something that suddenly makes the whole game experience just feel like something you haven't really seen before, instead of just changing the camera effect. It's kind of a nice way to handle all of this. So um, I I might do one last little thing just because I'll be honest with you, I'm kind of running out of steam.
Yeah, and
Um,
we're getting short
so
on time here as well. Did you want to show off
oh, okay.
the mannequin there and the world position offset?
Yeah, yeah, that's what I was gonna do really quick. So
You're
what's the
doing
best way
well,
to do
Chris,
this?
considering how late it
Yeah,
is there, and we
sorry.
can all see what time it is for you.
Yeah, it's up. Um, okay, so what I'm gonna do this time around is gonna create a new. No, I'm just gonna mess with the existing mannequin. All right, so if I was to look at the existing mannequin, which is opened up on a different screen somewhere, anywhere, there it is. So if I was to look at this existing mannequin, this is what we've got. Okay. Now, remember earlier I used the world aligned texture node to
Mm-hmm.
project onto this asset? So if we were to do the same thing with our mannequin, we would actually have a bit of a problem. So I'm going to ignore all of this. It's going to get everything that's coming out of that, and I'm going to call set material attributes. Trying to get material attributes. I'm going to get the base color, and I'm going to set the base color on the mannequin to be sorry, I'm just going to get a noise texture. I mean, I guess that'll do. And I'm just going to plug it in. Now, by default, we're going to have a bit of a problem. Now, if I was to multiply this value by like dark red, I'll go for red, just so it's visible. And I was to overlay this. Victor, are you there? I just feel like the
Yeah, yeah, yeah.
connection
We're
just
here. We're here.
dropped. Oh, yeah. Cool, cool, cool. All right, so I'm just overlaying this onto it. We would have a little bit of an issue. So I'm just going to hit apply. And I'm going to look at my mannequin.
Waiting for the shaders.
So yeah, that looks okay, right?
Mm-hmm.
Like it looks, well, yeah, okay-ish. The problem is this: if I was to apply an animation to him, can everyone see what's going on there?
Let's
So
see.
because it's a projection in world space, the asset is kind of shimmering. I hope my connection's able to like
I
make
think
that
it's coming
visible.
through. Yeah, we can see the textures sort of staying still in world space, whereas the mannequin
Yeah,
is moving.
exactly. Wonderful. So, quick little thing that I just want you to be aware of is, so for something like that, all you need to do is, if I call pre-skinned local position, so pre-skinned position actually gets me the world position before it was in when it was in its T pose. So, oh, and you've got to use a vertex interpolator for that. So watch, I'm just going to plug this in instead. Okay, so I'm just plug that in. What are we doing? Mannequin, where are you? Now, see what that's doing now?
In
If I
just
run
a
it in
moment, I
slow-mo,
think.
maybe that's better.
Okay, there we go.
So see what's actually going on there? That pre-skinned position, because it's the T-pose position, I can actually just project onto the asset, and even though it's moving around, it's actually just like those. You're not getting that shimmer anymore.
Mm-hmm.
Victor, it might be a good idea. I gave you some B-roll on this effect just before the live stream started, just in case. Do you mind playing that for me?
Yeah, what was the name of it?
It's called Local Bounds.
Coming right up.
Just the cheers, big ears. So you can see on the left-hand side is what you would normally get, and on the right-hand side is the pre-skinned local position. Now the cool part of this is like, if you drop back to my screen now, if that's okay.
Mm-hmm.
Now the cool part of this is, at the moment, this is using the world sizing. But if I wanted to, I can actually get this pre-skinned local position and I can divide it by the pre-skinned local bounds, which divides it by the size of the skeletal mesh when it was in its T-pose. And I'm going to set this texture size to be a value of 1. Because what this actually goes ahead and does is, by dividing it by the pre-skinned local bounds, it actually aligns the texture to be projected according to the size of the skeletal mesh, so you don't have to be finicky about what exact size the asset was. You can just have generic skins. Now, this is really good because think about if you're making a video game and you wanted to have camouflage on the character, so or you wanted to project like a cool decal onto their T-shirt or anything like that.
Right.
Being able to just read that information in means that what you end up with is like a really, really elegant and quick way to generate a ton of content. You can really quickly generate uniforms based off of camouflage textures being read in. You can really quickly, generate all sorts of weird and wonderful patterns that are just being brought in. And it really takes... I'm not saying to do that in a game for every skin, right? But let's say you had a game that you wanted to have like hundreds of loot, thousands of loot drops for the player. When you're able to use something like that to just really, really quickly generate a weapon skin for literally every weapon by just projecting that particular camouflage type into that particular region on the asset, that's really valuable because you can then use that for your smaller assets. And then you can still do all of your custom detailed hero assets that look really, really nice, that are the bigger features, right? And this is really important for developers because we want them, we want you to not get bogged down by workflow issues that just shouldn't exist. So when you're able to kind of get this pre-skin stuff and just project things onto characters or onto weapons or onto items in general, I shouldn't just say weapons, you can create a lot of value that you can keep rewarding players and just keep giving them all sorts of free stuff in your game, keep giving them drops, make things look interesting, and it's pretty great. So please keep in mind that the pre-skin local position and the pre-skin bounds are pretty valuable. So you can see the bounds here has just made this go between 0 and 1, and it's just kept it to a nice size and nice scale for the projection, which is great. Now the last little thing. So I'll be honest with you, I'm kind of out of time to really do the procedural gen stuff that I was going to quickly cover. So what I'm just going to do is load up a project and just show you some of the tools that exist, so that you can jump into that. My apologies for anyone that jumped into the stream. The proc gen stuff I originally intended on doing, but it kind of involves a lot of moving around and would have involved me moving quite quickly, and I wasn't quite comfortable doing that and not slipping up um, at this hour. That was all. So this world here has been procedurally generated. The forest has been brought in using the foliage procedural foliage volume tool. This is available for everyone. It's just go edit and then go to experimental under your editor preferences. So experimental, and you'll see that we have procedural foliage. And the procedural foliage system literally lets you set up rule sets that tell it. We'll open up this one. You can literally set up, this procedural foliage system is looking for these 3 types of trees. And if I open each of these trees just has some rules that I've set up that say how much shade they cast, whether they can grow when they're in the shade, how many seeds they spread whenever they're not pollinating, seeding. What's the word here? God, you can tell I'm a nerd. So like you set up all of these rules for these trees, and if I was to go back here and simulate it, it actually regrows that forest and it throws them all in. And this is a really, really useful little tool because it actually syncs up with the foliage tool. So if I generate the forest and then I'm like, nah, I can just remove those trees. You know what I mean? So we can still get like that nice little custom layer in there. It just saves you having to paint all of that because, like, I mean, why would you waste time? So like if you can just kind of drop that straight in and have a good time, that's it. Just means you can just like be like, look, give me a forest. I'm going to carve out the area that I actually need. Let's all move on with our day. So that's the first thing that I kind of wanted to touch on. Now, the next thing that I quickly wanted to touch on is this landscape itself. I'm just going to hide the trees for a second. This landscape itself is actually completely procedural as well. So if I go to my content browser, I'm just going to run the widget. So see this thing up here? I got stuck without internet for like 6 hours, and I was trying to look for a project to just knock together while I was waiting for something. It's a long story. And this was kind of what I cooked up real quick. So this tool, if I click here and hit generate, that generated, like see that ditch corresponds to here, or if I wanted to pull this across and be like, hey, let's generate that. And you can see here that dip is there. By the way, the foliage should just stick to your landscape because of how the foliage system works. So it will actually, even after changes to your landscape, it stays friendly. And as of 4.23, you can also have generic actors as foliage too, which is really great. Anyway, back on track. So being able to have this kind of system is reasonably straightforward. Now, this looks like something that would be complex, but it's actually really not. I'm going to open up this editor utility widget. This doesn't involve a single line of code. I'm going to open up this utility widget. This is all Blueprint. And I've literally just gone ahead and created the widget by just dropping in a display image, which is the preview. And then down the bottom, I've generated like just a bunch of sliders and a big old generate button. But if I look at that display image, it's using a thing here called preview mat. I'm going to open up the preview material. So this is what you see on that little clickable area. This literally takes in a height map called Landscape RT, which is what I called it. And I've been a little bit cheeky with how I've set this up to get contour lines working, so I could actually see what the height was really doing here by multiplying it by 10 and then fracking it. I'm going to preview that. By multiplying it by 10 and then fracking it, it actually gives me a nice gradient between all of these layer lines. And then by kind of just doing a little bit of extra math there, I've subtracted 0.5 and multiplied it by 2, which kind of gets the bright areas in the middle and the black areas along the side. And then heavy contrast, which gets me this. And then I'm just literally lerping in some green. That actually gets me like a nice little preview screen. But like that, this kind of math isn't too complicated, and it's actually just seeding off of a render target. Now, if I look at the actual logic involved, I'm going to go back to my graph. This is the entire thing. It's It's actually reasonably straightforward, and most of it, like these things down here, if I zoom in, all they're doing is saying on value changed, call this update variables function. Okay, so like that's all of those are doing. Every slider, every time I change a slider, it's just updating the variables. I hope my stream is keeping up with me here.
Yeah, it looks all right.
So when it calls update variables, all it's doing is when we first create the thing, I'm creating a dynamic material. Okay, I'm getting that dynamic material, and it's a really simple landscape generation material that I created. Like this is literally just a couple of noise functions. It's literally just a couple of noise functions to create something that looks like camera. There we go. It's literally some noise functions to create something like this. You see, and I've added like a scale value to make it bigger, and I've added an offset for different things. But it's actually reasonably straightforward in terms of what it's actually doing. Now, all I'm doing in this widget is literally getting this, and I'm calling, hey, I want to update all the variables. Your offset is just equal to what the slider has. Your scale is equal to what the scale slider is. Your reduction amount is what I'm using for that black area wherever I click. Your reduction size is this. Like I'm literally just running through and just setting up all of these things and just letting it do its job. The only thing that's unique here that's worth noting is, see this draw material to render target? So this literally takes a render target, and if you so I'm getting this draw material to render targets, and I'm automatically then just outputting the landscape render target from that. So that's creating like a black and white texture. And after that creates a black and white texture for me, anytime anyone hits the create landscape button, so anytime anyone clicks this big old generate button down here, what that's actually doing is it's regenerating it just in case. And then I'm being a little sneaky. I'm saying get all level actors and just grab the first landscape you find. And then we have this function here, which is really where the meat of what we're doing is. And a lot of people aren't aware this even exists. And it's called landscape import height map from render target. Now, by importing the height map from the render target, it literally just takes a black and white render target and sets that as the height of the landscape. And from here, I've done a couple of other little things. I actually generate a grass, a texture as well, based on the landscape. So I'm actually generating grass patterns based on the height map. So this is a separate material again that's getting rendered. This essentially is just looking at the slope and saying, hey, how slanted is it? All right, it's pretty slanted, maybe make it dirt. So essentially this is like a static version of that cliff painting that you saw earlier. Right. And the advantage of making this static instead of making this like a world projection like I had before is it's just a little bit cheaper, and it's a little bit easier for artists to modify because they can go over the top of that and be like, look, I can see that it's generated and added some no grass there, but I really wish it had some grass there. And just paint that in. Okay. So we can see that like by having that as a static thing that initially gets pushed out, and it's worth noting that look, this workflow is good right now, but it's not really where you want it to be. And honestly, it's why I was after thinking about it a little bit, was a little bit hesitant to do this as the core of the live stream, because if you go to edit preferences and you go to experimental, there is the landscape layer system. This here landscape layer system is a something that's experimental at the moment, which allows you to create blueprint brushes. So being able to kind of use the experimental landscapes whenever you're creating a new landscape, it's going to mean that render targets like this are just done on separate landscape layers rather than doing them using the functionality that you're seeing at the moment. So, and that's in 4.23 at the moment. That's something people can kind of
and that's the editor version you're working in now, right?
Yeah. This is all just vanilla 23, nothing fancy about it. But so like I said, like that general procedural system is probably much better for a landscape discussion in a future version of Unreal. Once those layers are kind of a bit more stable and everything's working.
Yeah, I'm sure we'll cover that.
Yeah, I would hope so. But like so the just a quick heads up for anyone that's fooling around with this stuff. Be aware that if you go to edit plugins, so if you go here, you'll see editor scripting utilities. This is really I think it's disabled by default, but it adds a ton of extra functionality that you can do. So it adds a ton of extra like little calls that you can do within editor utility widgets. And the other one that's really powerful is, I think it's called, blueprint material and texture nodes. So this gives you the ability to do blueprint only nodes for like creating static textures and all sorts of stuff. This is really powerful when you're doing procedural landscape widgets and such. So
yeah, we had Nick Pfister on a couple of months ago showing off how to use the editor utility widgets.
oh, wonderful.
We also have good documentation on that, pretty straightforward, how to get started.
Yeah. So with that said, I think that's probably the core of what I really was going to be covering today.
Yeah, that was quite a bit.
I guess it's a good idea for us to kind of go into a question. I might stop sharing and just switch back to video feed. You know, I'll deal with my 5:45 a.m. mug.
Yeah.
So I'll switch over. We'll go from there. So if anyone has questions from this point, I guess now's the time to do it.
We actually have a lot of questions. I don't actually think we'll be able to go through some of them, and I've been paying attention here. Let's see if we had some earlier that I'd be able to grab. Just one or two. There's quite a few. Would you be willing to maybe go through them and pick some out that are relevant and answer them later? Just on the forum is what I was thinking. Yeah, you know, you can get some sleep.
I could do it on the forum.
You can get some sleep, and then we'll take. How about we do that?
No, I can answer. I can still do 10.
You good?
If you want.
All right. Let's go.
Let's just
go through a few then. What a champ. Is there such a thing as vertex normal local space?
Vertex normal local space. I believe so. Yeah. Let's find out. Preskin. Oh, hang on. Where we go? We got preskins. Yeah, preskin normal.
All right. The answer is yes. And what was it called?
Preskins normal. So you've got preskins, preskin position, preskin normal. By the way, little thing, and I know this is weird, but a lot of people don't know this. Shift D aligns nodes to the right side. Shift A aligns them to the left side. Look at this. Shift D. Hang on. Just gonna add an extra node. This works in Blueprint as well.
Okay.
But it's just a nice thing to just keep your nodes. So there you go. So align left, align right. And if you ever have nodes plugged in like this, I'm not sure if you noticed that I was doing it, but if I was to click these and hit Q, it will straighten them and just auto fix your stuff. Just a lot of people aren't aware of Q, Shift A, Shift D.
You can also find all these options.
I find it really.
By,
oh wait! I just realized that you can't see my screen.
No, we cannot.
Yeah, sorry.
Next time.
This is what you get from
Next
me.
time. Yeah, that's also what makes going through the questions a little hard, because I know that you're just like, oh yeah, it's right there. Let me show you.
Okay. Yeah. I'm gonna ditch my video. Let's go back to the screen while I answer questions. Can you drop back?
Yep. Let's see. One moment. Just a bit. There we go.
Great. So yeah, if you hit Q, it'll just straighten your nodes. If I grab things like this and hit Shift D, Shift A,
you get dancing nodes.
Yeah, dancing nodes. It's just a good way of just not having to deal with straightening stuff manually.
Mm-hmm. Yeah, or marking them, right-clicking, and selecting the option in the menu.
Oh, yeah. God. Like,
oh God,
caveman?
menus.
Hotkeys, man. But yeah, so just be aware that's a thing. And the nodes that I was mentioning before, which I put on screen and then straight up forgot that I had, was just preskin local position, preskin local normal, preskin local bounds.
All right. Why is it called vertex interpolator if it's a pixel shader only node?
It's interpolating the values from vertex through to pixel, I guess. You'd have to ask the person that named it. But I believe that's why. Because I think it's getting your pixel values by, like, getting the verts, right? And then interpolating between them to get your pixel position, like the equivalent of on the pixel side. We're pretty sure we have documentation on it. But yeah, I believe that's why it's called that.
All right. They were curious if any of this content might be available after the stream.
I mean, the buildings that I did are public. Like I put them as files on my Twitter feed.
Mm-hmm.
What was the other ones that we had here? What else did I do tonight? Post-process stuff. I mean, I didn't do the post-process, but I mean that's pretty straightforward. I can send that through, and you can post that. I mean, the material itself was super straightforward, though. Like it's, I say super straightforward, but like
it's just nice sometimes to be able
to look at and just do.
Break
like
it down
and a couple of nodes. So I mean, if you want to, I can push that through. It's no big ask. I might do it after I've slept though. If that's all right. And yeah, but I mean that's fine. The material generation stuff I can send through to you if you want. It's kind of hacky because I've just like thrown it together, so it's pretty ugly to look at. Like I spent 0 time making the widget itself look pretty. I was like, functional, and then just called it. But I mean, if you want, I could post that up.
Yeah. We'll take a look at it after stream and see what we'll be able to share.
Yeah. Okay.
Let's see. See, these are all specific to what you were doing right then. Is any of the operations you've been doing in the material graph here SM5 only, or do most of them work on other platforms?
It's a good question. I don't believe so, but I don't want you to hold me to that because I'm not too sure about these ones. I haven't run them on. I haven't run them on a non-SM5 device. I think it's all fine though, but you'll need to don't hold me to that. You'll need to check it yourself. I'm sorry.
Yeah, it's fairly easy. You can turn on the ESGL 3.1 preview and just apply the same material in your scene there, and you can check it out.
That's true. So yeah, there's that. I'm not too sure about the building stuff. Yeah, I mean, like, sorry, I'm just thinking about it. Like, if it's your interior maps might have issues, but I doubt it. Look, yeah, I'm not going to answer that question on just because there's a bunch of materials there that I would have to go through to verify it today.
Mm-hmm.
To my knowledge, it's fine, but what I expect like ES 3.1 to do versus what it actually does aren't never anything but similar whenever it comes to advanced effects. So, yeah, a little tricky.
Sounds good. I think that was it in terms of what you covered and questions regarding them. It's also getting real late, and I know that you should try to get a little bit of sleep. Chris actually went to bed, and then he got up for the stream and recommended him to go back to bed. Yeah, true champ. See if we can get you back here so we can.
That's all right. It's the job. That's the job.
Certainly did.
But I mean, okay, so that was it for the core stuff, I guess. If there's anything else, there are no other big questions that have really kind of popped up that you can think of that I should jump in on?
In regards to, some of them don't have enough context for me to know precisely when they were asked, unfortunately.
When they were asked?
Yeah.
Okay.
So it's just, can you show some slight variation? Not entirely sure, unfortunately, when that was asked. So that's a good tip to all of you when you go ahead and face your question. Try to be a little bit specific about the question. Maybe you mention like, oh, when he was doing the landscape material or the post process, and then it'll be a little bit easier for us to know when that was asked. But yeah, that's really cool. A lot of cool stuff. And if you want to see some more work on this, now I'm also getting mumbled up here. Chris' Twitter profile is another good resource. You can go follow him there, where he frequently tweets about all these cool things. And I think it's kind of a cool idea that we get together and we show some little bit more exactly how you did some of these things on the live stream. I think that's a pretty cool concept. Sort of grab the best of what you've done recently and then go over it. So I think with that said, thank you so much, Chris, for coming on and doing this with me. For all of you who is still watching out there and stuck with us for this long, I'd like to let you know that we are doing transcripts of all of the live streams now. So on YouTube, after a couple of days, whenever the people who it's actually done by a person, so they go through, they listen to what we've said, and they write up captions. And that transcript we provide a link to in the YouTube description. And it's a good way for you to go and Control F and search for specific keywords if you were interested in a specific part of the stream. As always, we do have a...
sorry.
Go ahead, Chris.
I'm so sorry to whoever has to like translate my rantings when I'm trying to work out what I'm doing on screen.
That's mine and the captioner's job later on. Don't worry, you don't have to worry about that. As always, Amanda went ahead and posted a link to the survey. I think we're going to go ahead and do that again. If you fill it out and drop your email in there, let us know how we did, what you would like to see in the future. I generally go there and use it as a reference to what you guys want to see on the stream. And if you enter your email, you are part of a little t-shirt sweepstake that we're running. If you're interested in meeting other developers around the world, go ahead and go to unrealengine.com/user-groups, and you'll be able to see if there is a meetup group near you. If there is none, and you know you have a group of friends or people there that are excited about showing off what you do, go ahead and send us an email to community@unrealengine.com, and we can tell you all about what it means being one of our meetup organizers. So always make sure you check out our forums. We have an unofficial Unreal Slackers channel on Discord where people are really helpful. You can ask your questions, or if you have any problems, let them know and try to get some, or even just feedback. Facebook, Reddit, you know the deal. That's where we're at. Our community spotlights that we have every week, we usually source them from our forums, but you can also just go ahead and ping us either on Discord or, like I mentioned, community@unrealengine.com. It's a good email address just to let us know about what you're working on. It's always really fun to see. We're still looking for more countdown videos, so 30 minutes of content of you working in the editor, speed it up to 5 minutes, and send us that together with your logo separately so that we can do the cool little countdown timer. Then we might go ahead and put you on as one of our countdowns. And if you're streaming on Twitch like we do, make sure you use the Unreal Engine category so that we can come and have a look when we have a couple of minutes in the day. And as always, follow us on social media and chat. Please give Chris your biggest thanks for sticking with us for 2 hours now. And technically, you've been with us since the prep, which is an hour before this. Half an hour before the stream, so 2.5 hours. Big up to Chris. Thanks again. Will you be at Unreal Dev Days next week?
No, I won't be. Actually, on that note, I will be at GCAP, which is Australia, New Zealand events. For any developers that are at GCAP next week, so next week is Melbourne International Games Week. We have a meetup going on the Monday night, which you can find through the Unreal Engine Melbourne meetup group. We'll have a couple of devs there.
That's on meetup.com?
Yeah, so just head to the Melbourne meetup and you'll see it there. But we're having just a general mixer for so there'll be a couple of epic folk floating around that can hopefully answer some questions. And for any of the Australian devs that might be attending, feel free to send me any videos that you've got, because we're running it at an esports bar in Melbourne, which has a bunch of TVs kind of streaming.
Cool.
So if you want, we're going to be running developers' games on each of those streams. So if you've got either a trailer or anything like that you want to put in there, or if there's a known stream that might be running, yeah, please let me know.
That's awesome.
Yeah. Otherwise, thanks a lot for having me, guys.
Yeah, as always, Chris. And if you are at Unreal Dev Days next week, we will be there, both me and Amanda, so please come and say hi. And with that, next week we will be, actually so there's a tool called Mod.io. I'm not going to talk too much about what it is right now, but because I want the people who actually made a tool, but they will be on the stream next week talking about how you can build a mod framework for your game. So that's going to be really exciting. That's Thursday next week. Until then, goodbye, and thanks everyone for hanging out.